All right, Secondary Math 1 class, we are going to be talking more about simplifying radicals. Today we are going to add in some variables with those. So let's get right into our notes. So for number 1, and I know we've done this like 4 times, but it totally helps. So we are going to list the first 11 perfect squares. So everybody make a list just like we've done from 0 to 10. So 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, and 10. Okay, so make sure your list looks like mine on your notes, all the way from 0 to 10. Okay, so now what we're going to do is we're going to take these numbers and we are going to multiply them by themselves. Okay, so we're going to multiply 0 times 0, 1 times 1, 2 times 2, and so on and so forth. Okay, so fill in the rest of your list like so. Okay, so now your numbers are just multiplying by themselves. Okay, well now let's rewrite them using exponents. So 0 times 0 we can rewrite as 0 squared. 1 times 1, 1 squared. 2 times 2, 2 squared, and so on. Okay, all the way until we get to 10. Okay, so now your list should look like mine. All right, now what we're gonna do is we're gonna figure out the number that these actually equate to. So what is 0 times 0? It's gonna give me 0. Okay, what's 1 times 1? It's 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. And 10 times 10, 100. Okay, so for number 1, you should have a list that looks like mine. So these numbers in blue are all the numbers we really like. These are numbers that we get perfect squares when we square root them, right? So now what I want us to do is I want you to look at numbers 2 through 5, okay, just these next 4 problems. And I want you to see if you can see any of the numbers from our blue list. Okay, are any of these numbers in blue under the square root signs? Okay, if they are, I want you to put a star by them. Okay, so I only see one number that was on our list in blue. Okay, this is number 3. This is a square root of 36. Okay, so once you've placed a star by that, go ahead and just leave it there for a second. And let's look at number 2. Okay, so number 2, it's asking us to simplify the radical, which basically means find the square root of this number. Okay, well 20 is not a number on our list, right? It jumped from 16 to 25. So 20 is not a perfect square number. Okay, but that's okay. All we're trying to do is find pairs that can pair up and leave the radical, right? So the first thing we need to do is we need to start breaking 20 down. And when we break it down, that means we're dividing it. Okay, so how do we want to divide 20? Okay, well, we know that 20 is an even number, so we can divide it by 2. And that is going to give me 10. 20 divided by 2 gives me a 10. So the 20 we broke down, it's not there anymore. So I don't have a square yet, or I don't have a pair of numbers that can leave, but we can continue to break down. So let's divide 10. How can we divide 10? Okay, again, it's even, so we can divide it by 2, and 10 divided by 2 is going to give me 5. Okay, well now that all my numbers are as broken down as they can be, what is my number that can pair up to leave the radical? Okay, I see 2 2s right here. They create one couple, right? We're thinking going on a date. They can pair up to go on a date. They create one couple. What is the number that is left inside my radical? 5. Remember, we're not looking at 20 and 10 anymore because we broke them down. So my only 3 numbers that were left were 2, 2, and 5. 2 could pair up to leave. 5 had to stay inside. So our simplified radical is 2 root 5. Okay, let's look at number 3. Okay, what's so great about number 3? We put a star by it. Okay, well 36 is on our list, right? What is the number that multiplies by itself to give us 36? 6, right? So we could look at 36, and if we wanted to break this down, we can say 6 times 6 gives me 36. Well, there is my automatic pair of numbers that could leave my radical. So I know that the square root of 36 is 6. Alrighty, let's look at number 4. Okay, so 45 again is not a perfect square number. There's no number that multiplies by itself perfectly to give us 45. So we need to start dividing it. Okay, well 45 is not an even number. So how do we want to divide it? Okay, it ends in a 5, so I know I can divide it by 5. So 45 divided by 5 is going to give me what? It's going to give me a 9. Okay, and I love 9 because if you look back up at our list, 9 is one of these awesome numbers that gives us an automatic pair that can leave. Okay, so in other words, I can know that I can break 9 down to 3 and a 3. And what is my number that can pair up and leave? Okay, my 3's create that couple. My 5 is the only number that's left since we broke 45 and 9 down. So 5 has to stay inside. My simplified radical is 3 root 5. Okay, let's look at number 5. So I have root 18. Okay, so it's not a perfect square. That's okay, we know we can start dividing it down. So how do we want to divide 18? It's an even number, so I know I can divide it by 2. Okay, 18 divided by 2 is going to give me 9. Okay, again, 9 is one of these great numbers that gives us an automatic pair. So I know 3 times 3 gives me 9. So what is my pair that can leave the radical? Okay, 3 can pair up, they create one couple, and the only number that's left is that 2. So my simplified radical is 3 root 2. Okay, perfect. So let's look at numbers 6 and 7. Okay, so the only difference between 6 and 7 and 2 through 5 is now we have this number that's out in front. Okay, well if we're thinking like going on a date, couples that can go on a date, just think that this is a couple that's already outside the house. They're already on the date. They're waiting to see if there are any other pairs that can create a group date with them, right? So we're gonna just ignore that 6 for now. Okay, so how do we want to break or divide 40 down? Okay, we know it's an even number, so we can divide it by 2. That'll give me 20. Okay, I don't have a pair yet, but let's keep dividing. I can divide 20 by 2. It's going to give me 10. Okay, I see a pair, but let's see if we can break down any more to get any other pairs. Okay, because we don't want to leave any pairs out if we can break them out. Okay, so let's break 10 down. We can divide 10 by a 2 and a 5. Okay, so we know that there's one couple of 2's that got to leave. Did any other couples get to leave? No. Okay, so these guys, since they can't couple up, they just turn back into that 10. Okay, so the only couple that got to leave was our 2, and then our 10 had to stay inside. But we're not done because remember, there was already a couple that was waiting out there. So 6 is now going to multiply by that 2. Okay, so what is 6 times 2? What's that going to give us out there? It's going to give me a 12. And the 10 still has to stay inside. So our final answer is 12 root 10. Okay. Let's look at number 7. So again, we have a couple. We have a number that's waiting out there, so we're just going to ignore it for now. Okay, but look at root 45. Didn't we already break down root 45? Okay, why would we want to break it down again? Okay, if we wanted to, we can do the exact same thing. I know 5 times 9 gives me 45, right? And then 9 gives me a 3 and a 3. Okay, so I know that that 3 can couple up and leave my radical. They create one couple. Okay, the 5 was the only thing left inside. Okay, and we're not quite done because of our number that was waiting out front. So this negative 2 is now going to multiply by our 3. So what is negative 2 times 3? What's that going to give me on the outside? It's going to give me a negative 6. And the root 5 still stays the same. So our final simplified radical, negative 6 root 5. Okay. So let's look at 8 through 11, our last 4 examples. So if you'll notice on these 4, what do they have that we haven't seen before in radicals? Okay, they have variables, right? We have letters in here. Okay, so we're going to start it the exact same way. Okay, so let's look at number 8. So I have root 27 with 1v. Okay, so we're just going to ignore the v for now. We're just going to treat it just like root 27. Okay, so how can we divide 27 to try and find some couples? 27 is not an even number, so how can we divide it? I know I can divide it by 3, because 3 times 9 gives me 27. Okay, well 9 is one of our favorite numbers up here in blue because it automatically gives me this pair. So 9 I know I can break down to 3 times 3. Okay, well now I know that one couple of 3, and again it doesn't matter which 2 3s you grab, but one couple of 3 can pair up. What number was left inside my radical? Another 3. Okay, but we're not quite done because now I have a variable. So the variables act just like the numbers. We need a pair of them in order to leave the radical. Okay, so we only have one v here. So can this v pair up with another v in order to leave? Nope. So my v has to stay inside. Okay, so same thing. Variables have to pair up with variables, just like numbers have to pair up with numbers. So our final simplified radical is 3 root 3v. Okay, so let's look at number 9. Okay, so let's just ignore the p for now. Let's just break down 96. Okay, so how can we break down or divide 96? Okay, well I know 96 is an even number, so I can divide it by 2. 96 divided by 2 is going to give me 48. Oh, so close to 49. Not quite. Okay, I can keep breaking down 48 to 2 and 24. Okay, I have one couple that I see, but let's not stop there. We could have some more. Okay, so let's keep breaking down 24. 2 and 12. Okay, and I'm actually going to bring this up here just to give us some more room. Okay, how can I break down 12? 2 times 6. Okay, I see another couple. So there's another couple of 2s that got to leave. Okay, let's break down 6 to see if there are any others. Okay, 6 I know I can break down to 2 times 3. That's as broken down as it'll go. So can these guys pair up? No, so they turn back into that 6. Okay, so let's see what got to come out. So I see one couple of 2's here, but then another couple of 2's got to come out. So that means one couple, 2 couples got to come out. Okay, what number had to stay in? Just that 6 at the very end. Okay, so we're not done. What is 2 times 2? We got to simplify out front. It's going to give me a 4. Okay, root 6 had to stay in. But now we need to look at our variables. So let's go back. So again, we need variables to pair up in order to leave. So I only have one p. So can my p leave the radical? Nope, there's only one of them. So my p has to stay inside. So our final simplified answer, 4 root 6p. Okay, and there's that whole problem we did right there. Okay, so let's do it some more. Here we have number 10. So now I have 2 variables in here, but that's okay. We're gonna just ignore them for now. So let's break down or divide 72. Okay, so 72 I know is even, so let's go ahead and divide it by 2. 72 divided by 2 is going to give me 36. Ooh, I love 36 because it's one of our numbers up here, which gives us an automatic pair. So I know 36 can divide to 6 and 6. Beautiful, we broke 72 down. So I see a couple that got to leave here. Okay, but let's leave some space because there might be something else that can leave. Okay, so I'm going to leave a little bit of space between 6 and my radical. Okay, so let's look at my m's. Okay, so I'm going to do m's in purple. So I have m cubed right here, which really means m times m times m. Okay, how many m's can couple up and leave? I see that 2 of them can couple up and create one couple of m's that got to leave. How many m's had to stay inside? 1. Okay, and what was our number that actually had to stay inside? We forgot to write that. What is my number that had to stay inside when breaking down 72? 2. So we know that 2 had to stay inside. And then we know that 1m had to stay inside. So 2 m's got to couple up and leave. 1m had to stay inside. Okay, so now let's do our n's. Okay, so I'll do my n's right here. N cubed again, so n times n times n. How many n's can couple up and leave? So 2 of them. They create one couple that got to leave. And how many n's stay inside? 1n. So our final simplified answer is 6mn root 2mn. Okay, the 6 got to couple up and leave. One couple of m's got to leave. One couple of n's got to leave. And 1m and 1n left over. Okay. Last example. So we're going to ignore the u and the v for now. Let's just divide 32. Okay, so 32 is even, so let's go ahead and divide it by 2. 32 divided by 2 is going to give me 16. Ooh, and 16 is a great number because it automatically gives us a pair. So 16 I can break down to 4 and 4. Okay, so we know that 4 is our number that gets to couple up and leave. Okay, let's leave a little space in case anything else gets to leave. What is my number that had to stay in? It's going to be that 2. Perfect. So now let's look at our u's. Okay, so I have u cubed, which means u times u times u. How many u's can couple up and leave? Okay, they can create one couple of u's. And how many u's had to stay in? Just 1. Okay, now let's do our v's. V squared is really v times v. So how many v's can couple up and leave? Okay, they can both couple up. They make one couple. And did any v's have to stay inside? No. So our final answer, 4 UV root 2U. Okay, those are your notes for today. Make sure that you do the assignment below in Canvas.